On this 2014 to 2018 GMC Sierra 1500 with the 5.3 gas engine, P0325 points us toward the knock sensor 1 signal circuit. In plain terms, the control module may not be seeing the sensor signal it expects, and this code is treated as an open signal circuit fault. The truck may still run, but it can retard ignition timing to protect the engine from damaging knock, so the customer may notice reduced power or a different engine response. Broadly, possible fault areas can include the knock sensor circuit, the sensor connection, wiring or terminal issues, sensor condition, or in the right branch, the engine control module. Before getting deep into it, start with the basic system checks, follow a structured diagnostic approach, and make sure you understand the test setup before backprobing or disconnecting anything. For P0325, treat the running conditions as a monitor gate, not as a parts diagnosis. The open circuit monitor runs with the engine running for greater than 200 engine revolutions and for greater than 2 seconds, with engine speed from 400 to 5500 RPM for greater than 75 engine revolutions. The code sets when the signal circuit is open for greater than 5 seconds. In the related circuit fault logic, a signal circuit short to ground for greater than 5 seconds or a signal circuit short to voltage for greater than 5 seconds points you down different branches. That timing helps separate an open circuit P0325 path from the other signal circuit faults in the same knock sensor family. With the engine running, check whether P0325 is present by itself, or whether other knock sensor or module-related faults are also stored. If other codes are present, check what they mean first instead of forcing every fault through the P0325 path. If this signal circuit fault is the one you are chasing, move into circuit testing. If the relevant codes are not currently set, look at the scan data. Cylinder 1 through 8 knock detected should read no. While watching that parameter, wiggle the harness and connector at the B68 knock sensor. Then wiggle the harness and connector at the K20 engine control module. If the parameter changes during that movement, repair the wiring, terminals, or connector problem as necessary. If the code is not currently active, reproduce the operating conditions, or reproduce the captured conditions from the fault data. Then verify whether the code resets. If it does not reset, call it all okay for now. If it resets, continue with circuit testing. If the scan and code direction points away from the open circuit P0325 path and toward a knock performance type concern, do not skip the mechanical checks. Inspect the B68 knock sensor for correct installation, interference from brackets, wiring, hoses, lines, or other nearby parts, and visible damage. The sensor mounting surface needs to be clean and free of burrs, casting flash, and foreign material. Also keep in mind that over-tightening the retaining bolt or dropping the sensor can damage it. If the sensor area checks out, look for vehicle conditions that can create knock or noise, like accessory drive issues, belt-driven device problems, engine mechanical condition, or contaminated or poor quality fuel. If all of those checks are normal on that branch, the path allows testing or replacing the B68 knock sensor. Now for the P0325 circuit test. Turn the ignition and vehicle off, then disconnect the appropriate electrical connector at the B68 knock sensor. Turn the ignition on with the vehicle in service mode. The control module input for signal terminal 2B has internal resistance connected to 1.33 volts. So test between signal circuit terminal 2B and ground. You should see 1 to 2 volts. If terminal 2B is less than 1 volt, turn the ignition and vehicle off, disconnect the appropriate K20 engine control module connector, and test terminal 2B at the component harness to ground for infinite resistance. If it is less than infinite resistance, repair the short to ground. If resistance is infinite, test from terminal 2B at the component harness to the other end of the circuit at the control module harness. You should have less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, that branch calls for replacing the K20 engine control module. If terminal 2B is greater than 2V, turn the ignition and vehicle off, disconnect the K20 engine control module connector. Turn the ignition back on in service mode, and test terminal 2B at the component harness to ground for less than 1 volt. If it is 1 volt or greater, repair the short to voltage. If it is less than 1 volt, that branch calls for replacing the K20 engine control module. If terminal 2B is in range at 1 to 2 volts, move to signal terminal 1A. The control module input for terminal 1A has internal resistance connected to 5 volts. Test between signal circuit terminal 1A and ground. The expected reading is 2 to 4 volts. If terminal 1A is less than 2 volts, turn the ignition and vehicle off. Disconnect the appropriate K20 engine control module connector, and test terminal 1A at the component harness to ground for infinite resistance. If it is less than infinite resistance, repair the short to ground. If resistance is infinite, test terminal 1A from the component harness to the other end of the circuit at the control module harness. You should have less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, that branch calls for replacing the K20 engine control module. If terminal 1A is greater than 4 volts, turn the ignition and vehicle off. Disconnect the K20 engine control module connector. Turn the ignition on in service mode and test terminal 1A at the component harness to ground for less than 1 volt. If it is 1 volt or greater, repair the short to voltage. If it is less than 1 volt, that branch calls for replacing the K20 engine control module. If terminal 1A is between 2 and 4 volts, after terminal 2B also tested correctly, the path calls for replacing the appropriate B68 knock sensor. After the repair, keep verification separate from testing. Verify the repair and confirm the code stays gone under the proper operating conditions. Bottom line, for P0325, do not guess at the sensor first. Prove the signal circuits, check the harness and connector behavior, and only follow the replacement branch when the test results put you there. For more diagnostic training, visit stepdiagnostics.com.